So this one says you've got a function which is that they say it p is greater than 1. They say on one set of axes, sketch the graph of f and the derivative of this one. Show all intercepts and turning points expressing this in terms of p in the graph. Well, this one we can see is a parabola. All right, so I'm gonna take f of x. F of x first. When we investigate here, the p was positive, but we're timesing by minus, so it's gonna be minus. So the graph, we know it's a set vase. We know that. So from there, we can now find the y-intercept. Y-int, come on, you know x must be 0. When you put 0 everywhere where there is x, you're going to find that the y is 0. Okay, next one, we want the x-int, x-intercept. You make the equation equals to 0. So what you can do, factor out x. So I'm pulling out x. Then I'm left with minus px plus 2p equals to 0. So one of the first one is x equals to 0. It's one of them. And then if I saw this minus 2p will go there. So which means I'm going to have minus px equals to negative 2p divided by negative p, negative p. You end up with x equals to 2. There we go. All right, so I've got the turning point. Now you want the turning point. You can get that by derivation, by derivative. All right, so let's just do that because you are used to, or you can use minus b all over 2a, but let's do it by derivative. I'm deriving that, so it's going to be minus 2p x plus 2p. We equate that to 0. Then we solve for x. So we got minus 2px equals to minus 2p. You divide by minus 2p, x equals to 1. X equals to 1. Okay, let's see where is the y value. When you put 1 here and 1 here, you are simply left by minus p plus 2p, which gives you nothing but p. So that means the y value of the turning point will be b. All right, now you know where to sketch the graph. So to sketch that first graph of ours. All right, so in my mind, I'm like, okay, there it is, there it is, there it is. I'm going to say, oh, x-intercept is 0 and 2. All right, it's more to the right. So here's the 0 here by the white dot. And then I can put the 2 there. In the middle with the blue, I'll put a 1. So the turning point, x is 1, which means it could be here. And then that one must correspond with that. Okay, it's not going to correspond with that. But it's funny. No, it's right. It's right. They say it's greater than 1. Because here x is 1, y is greater than 1. So I'm supposed to do it this way. It must turn somewhere there above. Yeah, so it's going to turn somewhere there by the dot. All right, so when I turn it for me, then it has to come like that graph, and then it has to come like that for me. All right, so that coordinate at the top there, it will be p-value. So I've got x is 1, the y value is p. There we go. Now, when we do the derivative, it's basically a straight line, but let's derive it. I know since it's a surface, it needs to pass through that one somehow like that. But let's not be too crazy. Let's derive that. Actually, when we derived it, this is what we got for the derivation. So I'm going to call it y prime equals to minus 2 px plus 2p. To get the x-intercept, you make y 0, which is what we did, and we get x as 1. So that means I'm right there by the 1 there. But then to get the y-intercept, you put 0 in place of x. So when you put 0, this is gone. You've got 2p. So 2p must be above that p there. It must be a line way up above. Let me kind of shift it up there. There we go. Maybe we can put it here, right at the top there, and say, guys, we've got 2p. Then we can bring an orange line to pass through that. Then it must go something like that, but let's just make sure it passes through those 2 points. Okay, so it's gonna be like that. All right, so this is f prime of x. That is the derivation thereof. All right, so this one was nice and beautiful. Let's see. All right, so, oh yeah, this will be the last portion. And then they say now, show that the points of intersection of the graph and an inverse will always be independent of the value of x, but we just did. They say the points of intersection. So the points of intersection of the 2 graphs. So we just need to equate the 2 graphs. Yeah, this one sounds familiar also. Did I really finish this? So I'm going to take px squared, which is that original graph, plus 2p. Plus 2px. I must equate it to the derivative here. Minus 2p plus, 2px plus 2p there. Let's just say minus 2px. Yeah, there we go. So when we do that, you can divide everywhere by p. The p will be gone, will be gone, will be gone, will be gone. You're left with minus x squared plus 2x equals to minus 2x plus 2. So the p is gone. That's good enough up to here. So you have shown the p, it's gone. I don't need p to calculate that equation, those points of intersection. Wow, I don't know much now. That means I